Hey, what is up, everyone? Great to see everyone again. Let's just make sure we are good to go. Yep, looks good. Today we're going to be talking about building and using external adapters as part of the Chainlink Spring 2022 hackathon. So we'll just give everyone a couple minutes to come in, and then we'll get started. Can everyone hear me okay? Awesome. All right, we'll give it one more minute and then we'll get started. How's everyone's hackathon going so far? Can't wait to see what everyone's building. Thanks for the feedback on the video. We'll see how it goes once I get started. I'll keep an eye on the comments. Alrighty, let's get started. Let me know how the video goes, guys, but hopefully it cleans up a bit. Cool. So today we're going to be talking about building and using external adapters as part of the Spring 2022 Chainlink Hackathon. This is a really cool topic that I'm very passionate about, and I'm really excited to talk to you guys about it today. So my name is Harry Papakarisiou, and I'm a developer advocate here at Chainlink Labs, and we work on building Chainlink here. And basically, here's the agenda today. It's not a lot of presenting. A lot of it's going to be coding along. So we're going to just do a quick recap on what any API means. Then we're going to introduce the concept of external adapters. Then we're going to spend some time building a full end-to-end demo that uses an external adapter. So we're going to have a smart contract that makes a call to a Chainlink node. We're going to have a Chainlink node that is going to use an external adapter as part of a job, and then it's going to fulfill the job request, and then we're going to make a state change on our smart contract. And then we'll close things up by talking about where you can go to get help as part of your Spring 2022 Chainlink Hackathon project in the context of external adapters. All right, let's do it. So before we can talk about adapters, let's do a quick recap on Chainlink's AnyAPI functionality, right? So for those who may not know, Chainlink AnyAPI is gives smart contracts the ability to reach out to APIs from a smart contract, right? And it basically does this using what's called the request response model, where a smart contract will make a request to a Chainlink node or nodes for a job to say, hey, I want to reach out to this API here. I want to call this job, which is going to reach out to this API, sorry. And then the Chainlink node will reach out to that API. It will do everything that's specified in the job, right? And once it has a response, it will send a response back on chain, and it ends up making its way back to the smart contract that initiated the request. So basically, Chainlink adapters are what allow Chainlink oracles to integrate with these external APIs, right? And they're split into what are called core tasks and external adapters. So core tasks are just your core tasks that come as part of the Chainlink node software here, as you can see. And your most common task for doing these API calls on the Chainlink node is a HTTP task, right? And this allows you to just do any normal HTTP GET, POST, PUT, REST type web service call to basically an API. And for many API calls, this is sufficient. So this standard HTTP task does the job for just these simple calls, right? However, we also have what are called external adapters for scenarios where a normal HTTP GET, POST, or PUT just doesn't cut it, right? If you need some more customization, or if the call is a bit more complex than that. So external adapters basically allow you to connect to APIs that aren't reachable via the standard HTTP task that I just showed you guys. And basically they do this by implementing a standardized API with a structured input and output JSON specification, right? So an external adapter is an API in itself, and it takes a specific input type and it outputs a specific JSON output as well, right? So when I say external adapters, just think of it as an API that accepts a HTTP post request with a certain format and then posts a response back, right? And external adapters can actually be written in any language, right? They don't have to be written in JavaScript or TypeScript. They can be written in Go. They can be written in Java. They can be written in whatever you want, as long as you can publish and run an API that adheres to the specification of the node software, right? Then you can have that as an external adapter, right? And so this is exactly how Chainlink uses these external adapters to reach out to any API that's available on the internet, right? And these can be run on the same machine as Chainlink node using it, or you can run it on a separate machine, including in the cloud and things like that as well. Right, so external adapters are what really gives Chainlink nodes a superpower to be able to connect to anything in the world, right? Any API that you want to connect to with your smart contract, you can do it with an external adapter because it just allows for so much flexibility and customizability. So in terms of where it sits on the stack or on the diagram, you have your blockchain or smart contract reaching out to a Chainlink network or Chainlink node to say, hey, I want to connect to this API or do this, run this job. And the job will basically, if it's defined that way, it'll reach out to an external adapter, which once again, remember, is an API in itself to say, hey, I'm going to call you, here are the input parameters. And then the external adapter will then, call out to the external API that it's defined for. And then the response will come back to the external adapter. The external adapter will send it back to the node, which will send it back on chain, right? So the external adapter can be split into two kind of sections, as I alluded to earlier. We have the requesting data from the external adapter and then the returning data, what the external adapter sends back. In terms of the format of the JSON input for requesting data, so we have an ID that can be passed in, which is optional, but it can be used for, can sometimes be used for debugging and things like that. There needs to be a data tag in there, right? Even if it's empty, it has to be something, a tag called data. And there's a couple other things, meta and response URL, which are optional to do some other tasks such as, asynchronous callbacks and things like that. However, here's an example here of a requesting data. So this is an example of calling an external adapter and passing the correct JSON input data that's required. So we have the optional ID field here. This is the job run ID or the request ID. And then we have our data tag, right? And in this case, it's not empty. We're passing in parameter foo with a value of 42 here, right? And there's a meta tag here as well. But this foo tag here with the 42, this is what's used to pass input data to the external adapter. So in terms of the external adapter then returning a response back to the Chainlink node, you can return back the job run ID if you want as well. Once again, it's useful for debugging purposes. But once again, you need to have a data tag, right, with some kind of response in there. So here's an example of returning data from an external adapter back to a Chainlink node. In this case, we have the job run ID here, 1, 2, 3, and then we have our data tag that's required. In this case, we're returning a few bits of information here. We have a symbol, ETHUSD, and then we have a last tag here, and then we have price, size, and timestamp. So these are all returned to the job on the Chainlink node that used the external adapter. If the endpoint gave a known error, the error field can also be included in the response back to the Chainlink node. And here's an example of what an error response payload can look like here. So some job types support external callbacks on a Chainlink node, right? So when it's supported, Chainlink could provide a response URL alongside the request payload. And if the external adapter wants to return data immediately, it can simply just respond with the data directly as normal. However, if you want to use a response URL to send later, it can initially just return a response like this, right? And in this case, the job on the Chainlink side on the node side will be put into a pending state, awaiting data which can be delivered at a later date, right? And when the external adapter is ready, it can call back to the node to resume the job run, basically, and this will resume the job on the Chainlink side. So you might think, all right, external adapters sound cool, but why do I need to use them? So there's specific instances in which you should use an external adapter, right? So if the first one is if you're doing computation that's expensive or not good to do on chain, such as iterating through a big chunk of data or something like that, that's a great scenario for doing it with an external adapter. Another good example is if you're reading data from something like a database or something where the API is not just a normal HTTP get or post or put, where you've got to put in authentication tokens and things like that and all these kinds of customization, it's a great scenario to use it then. Another suitable scenario is if you've got custom functionality as part of the API call, such as, let's say you're reading in a file and you want to hash the contents to IPFS, right? You can do that as part of your external adapter logic, right? So that's another good scenario for using an adapter or for privacy reasons, right? Let's say you have an API key that provides access to unlocking a car, for example, as part of your API call. You don't want to have this data on chain, so you can do it off chain with an external adapter. Cool. So that's kind of it in terms of the high-level overview of external adapters. It's a great question in the chat here. I'm just going to promote it. When the output of the API is not in JSON. So that's a great question. So like I said, an external adapter, you can have any logic in it that you want. So maybe there's no output in the API call, right? Let's say it just connects to a database on some enterprise server. That's fine, as long as in your external adapter logic, when you do that API call and it's successful, you just need to return a JSON response back to the node, right? Even if the API call doesn't have a JSON response. So you just need to return a HTTP 200, okay, and you can just have an empty data field, right? You don't need to have anything in data. So just because the API doesn't return JSON or support JSON doesn't mean you can't use it still. And yes, Lucas, using external adapters allows you to use off-chain data in a smart contract. So you'll see in the demo here, we'll return some off-chain data into our smart contract. So yeah, it's a great scenario for doing that. So in terms of the demo that we'll go through now, what we're going to do is we're going to basically do a full end-to-end example of an external adapter. So the first thing we're going to do is find an API to look up some off-chain data that we want to use in our smart contract, right? And then once we've defined the API that we want to use, we're going to create an external adapter around that API, right? So we're going to build it based off of a template that we have. And then once we have an external adapter created, we're going to create a job on a Chainlink node that uses the external adapter, right? And then once that's done, we're going to create a very simple smart contract that uses the job that we created on the node. So the smart contract will request the node to run the job. The job will call out to the external adapter, and then we'll get that off-chain data from the API through the node back onto our consuming smart contract. So what I'm going to do now is I'm going to switch to, here we go. So data that I've chosen for today's demo, I don't know how many of you guys are gamers or not. Feel free to let us know in the chat. We're going to be looking up some Halo gaming data, some Halo stats data. So there's a website here called developers.halo.api.com, which I will post in the chat. And basically, this is an unofficial Halo API for a bunch of Halo games where you can fetch player stats, matches, service records, get clips, message of the day, and all these types of things. So I thought this was a cool example, seeing as I'm a gamer myself. If we can get some Halo player statistic data on chain in a smart contract, you can imagine a scenario where you have a smart contract facilitating a payment for maybe a Halo tournament or something, where the winner or the winning team gets a bunch of ETH locked up in a smart contract. So this is the API that we're going to use. In terms of the specific endpoint on the API, the first thing we need to know is that this API is not open. You need to get an API key to access this API. So I pasted the URL in the chat for this API for those that want to play along together, or if you want to do this after. There's a link here that says claim your API key here. You need to follow that link. You need to sign in. You need to follow the steps here, navigate to this link, sign in with a Microsoft account, and then you receive a token in the response URL here, right? So once you have that API key token, then we're good to go, right? So in terms of the API endpoint that we're going to be looking at, we are going to, I'm in the docs section here, we're going to look at Master Chief Collection, and I think we're going to look at the player XP endpoint here. So cryptum.halo.api.com, so the endpoint is games, HMCC, stats, players, the player gamer tag, or player ID, and then XP. So I have a REST client open here just to show you guys what that API endpoint looks like. Hopefully that's big enough. So here you can see the endpoint here, cryptum, halo.api.com, games, stats, players, and player gamer tag here are Frosty we're using for the example today, and then XP. And in terms of the request, it's just a HTTP GET here. As you can see, we have our authentication token specified in the header. So my token that I used for when I signed up to this, as per the link that I showed you guys before here, you need to specify in an authorization header here. So you go authorization, Cryptum token, and then you put your token in there. And then once you do that and you run the API, you see a bunch of stuff returned here. So you get a data tag, And this is where the information that we care about is. So we have XP, how much XP the player has, and then their rank. So we're interested in the rank. What's their ranking for Halo Master Chief Collection here? So the current rank here is 86. So this is the data that we want to try and get into our smart contract here, right? So so this is the API, and this is me running the API just with a REST client here to just show you guys what the request looks like in terms of how you have to build it up with the authorization header, as well as what the response looks like and what kind of data are we trying to strip out of the response, right? So cool. We've actually agreed on an API. We've defined it. We're like, yep, in our smart contract, we want to try and get the player ranking for a given player into our smart contract using this API. So that's all good. So next, we need to create an external adapter to use this API now. So how do we do that? So as I said before, you can create an external adapter in any language or form, right? As long as you can then have it running as its own API. So we have a couple of example templates to do external adapters. I'll just show you guys. So if you go to our GitHub repository and if you search for external, we have external adapters JS as a repository. And from here, I think if you go to packages, I'll paste this in the chat, examples, source here. So if for those who love TypeScript and are very much TypeScript people, we have a TypeScript template for creating external adapter that you can use here. I'm going to paste it in the chat. However, we've also got just a simple JavaScript template, which I'll show you guys as well. This is probably the easiest one, so it's probably the one I'll go with today. We have a simple template for creating a Node.js external adapter here as well. So it's like a pre-created template that does a simple API call in an external adapter using JavaScript Node.js. So this is the example we're going to go with today because there's probably more JavaScript people than TypeScript. However, like I said before, you can create your external adapter in any language that you want, as long as you can then expose it as an API. Cool. So I'm just going to grab the GitHub URL here. So I'm going to go to my VS Code window here. I'll make this a bit bigger so you guys can see. So the first thing we're going to do is clone that repository. So I'm going to say git clone url.git into Halo external adapter. So that created a folder here, Halo EA, that we're going to be working with. So I'm going to go into it. And the first thing I'm going to do is install all of the dependencies that are specified in the package.json using yarn. As you can see, that created a whole bunch of stuff here in the node modules. But essentially, all of the logic for this external adapter is in this index.js file here, right? So I'll just kind of go through it and explain what everything means. And if there's any questions in the chat, I'll get to it at the end of the building the external adapter section here. So essentially, this external adapter uses a couple dependencies in the Chainlink external adapter library here. So, and you can actually go in here and see we have a requester and validator here, right? So it uses those. So there's a section here for defining custom errors that can be returned if you want to do that as part of your external adapter. And essentially all this code does is it basically builds up a request, calls the API, and then sends a response back, right? So here we're defining this thing called custom params that defines the custom parameters to be used by the adapter, right? So these are all the type of input parameters that the adapter may be expecting. And then here in this create request section here, this is where we're building up the request, right? So we're using this validator class to kind of validate some of the input parameters and stripping some validated data out to then build up a URL that we're going to call in our external adapter. And then once that's done, we basically some parameters are being set to then pass to the endpoint. And then once that's all done, everything's kind of packaged together into this config here, and that's sent to this requester.request function here, right? And like I said, you can kind of see all the code here if you want to. It's all been created, so you don't have to actually do it, and you just basically have to specify what the input parameters and output and any custom logic that you want to specify here. So it'll basically do the API call to the URL that's specified, right? And then in the response, it will kind of validate some of the data here. In this case, it checks if this is a number, and then it will do a callback. So it will basically send whatever response it got from the API call, it will send back to the Chainlink node that called the adapter. So HTTP 200, okay, etc. And it will send the response, the full JSON response that it gets back in the response of the external adapter as well. So whatever it gets from the API, it'll publish that as the response. So that's it. It's really just a few lines of code in this template. There's a few other functions for if you want to publish the adapter to the cloud to run it as a serverless function. There's one for AWS, there's one for Google Cloud, etc. But today we're going to just focus on doing things locally just to show you guys the nuances of external adapters. So that's it in terms of the template. So the next question is, what do we have to do to then start modifying this to get it to call our Halo API here that we showed before? So the first thing that we need to do is I have my API key that I'm using here. We need to store it somewhere, right? And I don't want to store it in the code because it's not best practices. So we're going to store it in a .env file. So I'm going to go .env. It's going to create a .env file here. We're going to go API key equals, and I will grab my API key here. So we're going to read in this API key value as part of in the external adapter rather than storing it in the code, because the code might get published to GitHub, etc. We don't want to put our API key in the public realm here. So we're going to put it in a .env file. So to use a .env file in this project, we need to install the .env library. So I'm going to go npm install .env. While that's running, we're going to define it up here now. So we're going to go require, and then we're going to go .env.config. Cool, so that's that done. The next thing we need to do is we need to set our custom parameters. So if we go back to the API that we were running earlier here, we can see that we need to know what the gamer tag or player ID is because it needs to be put into the URL itself, right? So we basically need to accept that as an input parameter to the external adapter. So I'm going to go back here and I'm going to say we're going to get rid of this second one. We're going to change this one to player ID, and we're going to expect something in the JSON import called player ID. Okay. Then we don't need to define a different endpoint here. We're going to leave everything else there in the create request section. So now we need to basically grab our API key and basically grab our player ID from the input parameter. So we're going to go const API key equals, I think it's process.env.api key. Right, so because we're using the .env library, we can do this, and this will basically look for a .env file, and it will look for something called API key, and it will grab this value here. So that's that. And then the next thing we need to do is get the player ID from the input parameters. So we're going to go const player ID equals validator dot validated data dot player ID. Right, so this validator here is going to validate all these input parameters, right? So we can basically grab them from here after. So we can say validated dot data dot player ID. Cool. So that's that. So we've got those two values now. The next thing we need to do is set a URL. So currently it's set to this crypto compare URL. So we're going to go here. We're going to grab this URL here and we're going to put it in here. However, the gamer tag might change. It needs to be depending upon whatever the smart contract sends to the external adapter. So to facilitate this, we're going to basically go player ID like that. I think that should do the trick. So we'll basically grab the player ID from here and insert it into the URL here. All right, we don't need to deal with these two. The next thing we need to do is change this to just have our player ID that we've set as our input parameters. The next thing we need to do is the authentication stuff. So you guys might remember we had in our authentication header here, we basically had to set the authorization here with our API key token. We need to do the same thing in our external adapter. So I'm going to go const, and then I'm going to call it headers equals, define an object, and we're going to go authorization, and I'm going to go cryptum token API key. So I'm going to basically replicate this authorization here. So cryptum token, and then the value of the API key constant here is what we're going to go with. So that will build up a headers object here. The next thing we want to do is we want to include it in our config here. So as long as you insert it here and you call it headers, this request that will treat it and it will inject it as like actual JSON headers into the request. So once that's done, we can do the request. We're not going to bother with validating your results just yet. However, feel free to put in any custom logic you want for validation. So you can put in any kind of custom logic you want after the request is actually done. The last thing we'll do is we'll change the response to be response.data. So we're just interested in sending the data that's responded with here. Once that's done, I think that might be it. Let's take a look. So I'm going to save my file. Always remember to save your file. And then we're going to go yarn start. So the adapter is running. So it's listening on port 8080. So it's running on our local host. So what I'll do is now I'll go to a new terminal here, and we can actually test it. So I'm going to go to curl. We'll test it with curl. So we're going to do a post request. And in terms of our headers, we want to send content type equals application JSON. And the request that we want to make is to our local host at 8080. And the data that we want to send as an input. Here's where we need to build up our structured JSON input. So we want to send at first just an ID, like a job ID of say 1, doesn't really matter in this case. And then we want to send a data. We want to send a data tag. And then in that data tag, we want to specify a player ID, input parameter. And in this case, we'll put in Frosty again. We end that, and then we end that tag, and then we end the request. And I have a syntax error somewhere. Let's try again. So header, content type, application.json, localhost 8080, data, have ID of 1. Yep, then we have data, and we have, here's where I went wrong. Player ID, and Frosty is the input player gamer tag, and then the 2 closing brackets. Cool. See the response here? We get, in our data, we get the XP, but more importantly, we get in the rank section, we get the ranking that we're interested in. So our external adapter is now fully functional. We were able to successfully call it, passing in a player gamer tag, and it successfully reached out to the Halo API and returned the response. In this case, the ranking that we're interested in. And we can then use this in our Chainlink node. We can strip it out and then send it back to the smart contract. Right, so we've defined our API. We've built an external adapter that uses the API and that grabs the data that we want. The next step is to add this external adapter to our Chainlink node. Just seeing the chat here. Yeah, this job isn't an async scenario. However, if there's some time at the end, I'll show you some more info regarding that if we have time. So before we move on, a few hours ago, Richard from our DevRel team ran a really cool workshop for running your own Chainlink node. So that is a prerequisite to this workshop here now. So because the external adapter needs to be added to a node, you need to have a functioning Chainlink node to add it to. So I'll paste a link to Richard's awesome talk in the chat. So if you haven't checked that out yet, check it out. It will give you some handy hints on basically spinning up a Chainlink node. Once you've completed that and you have a functioning node that you can access the front end with, then we can start doing this next section now, right? So here I have my Chainlink node. It's probably going to be logged out now. So I'm going to log into my node. I'm running the latest version of the node software. I think it's version 1.3 here. So for those who want to follow along at home. So the very absolute first thing you need to do before you can use an external adapter is you need to add it as a bridge, right? So there's a section at the top called bridges. And a bridge is basically just a connection to an external adapter, right? So when you create a job that uses an external adapter, there's a specific job task that you'll see for that, and when the node goes to run the job, it will see that it's an external adapter task, and it will create a bridge or a connection to the external adapter. So we need to do that. You need to define that that bridge name here before you can use it. So I've already created one here called Halo, but I'll just show you guys how it works. So you can call it whatever you want. However, you need to remember the name because you're going to use it when you're creating your job as well. Then you specify your URL here, minimum contract payment in link, and confirmations if you wish. Right. So create a bridge with incoming access token. So if you want to have security on your call to this bridge, you can basically use this authentication access token here. We won't bother for today's demonstration. We'll keep it simple. So now that we've created our bridge or our connection to our external adapter, the next thing to do is to create a job that uses the external adapter. So we're going to go into jobs. I'll just make this a bit bigger. Hopefully you guys can see that. So if you go to our docs, it's probably the easiest way to do this. If you go to docs.chain.link, and then you go to node operators, and then there's a section on external adapters down here. And there's a section called bridges, adding external adapters to nodes, right? And if you go there, here, you can see it talks about creating the bridge. And then over here, you can see there's an example job that uses an external adapter here. So this is probably the easiest way to create a job, is to take this one and then modify it to suit. So I've just copied it here. And for those who know about the whole Chainlink node TOML format with creating jobs, you can see it's pretty much just like the same as like a normal direct request job where you're just going to reach out to a normal API. The only difference is we're using this bridge task here, right? So bridge task is defined here. It makes a HTTP post request to a pre-configured URL, right? So that's kind of the only difference between a normal direct request is this type here. And the name that you specify here needs to match the name that we specified here when creating the bridge. So in our case, it needs to be Halo or Halo 2, right? But other than that, creating a job that uses an external adapter is just like creating a job that does a normal API call, right? We have our decode log task, our ETH API decode log, which takes the emitted event on chain and looks for data, right? And then we have a CBOR pass task that strips out some of the data from that log. And then we have our fetch task, which once again, we basically say, hey, that bridge that we defined, we want to basically call that now and use it. And you can specify the request data that you want to pass to that external adapter, right? And then once that external adapter returns a response, you can, if you want to, if it's got like a whole bunch of stuff in it, you can do a JSON path to strip out a specific element from the response. And then once you have that, you can encode that data that you stripped out into an integer string, whatever you need. And then you do an ETH API encode to build up a transaction to send back to the Oracle contract or operator contract with the response, right? So that the Oracle operator contract can then send it back to your consuming smart contract. So very similar to a direct request. Notable difference is this kind of fetch section here. So I've taken a copy of this, and what I'm going to do is I'm going to go back to my node. We're going to go new job. And paste it in. So first thing I'm going to do is we'll call the job Halo EA. So the contract address needs to be your Oracle contract or operator contract for your node. If you're not sure what this is, go back to Richard's talk that on running a Chainlink node that I linked in the chat for an explanation on that. So in my case, I have my deployed Oracle contract running at this address. So I'm going to put it here in contract address, as well as here in my submit TX task, because I want to send the response back to the Oracle contract. The decode log can stay as is. I think we don't need to change anything in there. So once again, the fetch, the bridge type task here is what we want to change to use our external adapter. So because we named our bridge Halo or Halo 2, we're going to change the name to Halo here. And in terms of the request data, we want to pass in the external job ID, and we want to pass in that player ID parameter as well that we specify that we want to use in our external adapter. So I think in our case, whoops, coincidentally, the example from the docs already has player ID, so I don't need to change it. So in our case, it's like an Xbox gamer tag. In the external adapter scenario, I think it's a soccer player ID or something. But anyway, so it's going to pass in player ID from the request, right? And then once the external adapter is called, we want to strip out this current ranking here. So we're going to change the parse task, and instead of parsing data 0 games, we want to parse data rank current. If you go back to the response here, you can see you've got data rank current. And if you're running one of the later versions of the node, just a heads up, you need to use commas instead of dots to kind of traverse this path. So as you can see, I've done that here, data, comma, rank, comma, current. So it's going to strip out that value. And then we're going to encode that response back, and we're going to send it back. And I think that might be it. Trying to see if there's anything else we need to specify here. Nope, I think that's all good to go. So we're going to create that job now. Successfully created job 10. So as you can see, we have our job here. We've got an external job ID. This is what we're going to use in our consuming smart contract. So as you can see, we created a job. It's just a direct request job. And it basically is very much like a normal direct request job, except it has this fetch task here, this bridge task that looks at our bridge that we created called Halo, and it calls it and it passes the player ID. And then when it gets a response, it will try to strip out the data rank current value in the JSON response. It will encode that value as an integer, and it will send it back to the Oracle contract to then send back to the consuming smart contract. So we've successfully created a job that uses the external adapter. So now the last step after that is we just need to create a smart contract that uses this, right? So we can test it. So the easiest way to do that is to go back to our docs and go to EVM chains here. And if you scroll down, we have a connect to any API section here. And there's a make a get request overview here with an example smart contract for doing an API call. So we're going to use this as a basis for our test. So I'm going to open this in Remix here. So we're doing this all on the Kovan testnet. So API consumer, I'll make this a bit bigger so everyone can see. Cool, so the first thing we're going to do is change some of these variables because we're dealing with player rankings and not volume. So I'm going to change that to rank. I'm going to change this function name to request ranking. I will leave the fulfill method as fulfill. And we're going to change the integer that's defined in the fulfill function to rank, and we want to store it in this rank parameter here, right? So to use a job that uses an external adapter as part of your project, it's very much like doing a normal API call using a Chainlink node. It's just you specify the specific job ID for the job that uses the external adapter. So in this case, we have external job ID here. If I go back to my code, which was, where was it? Here. We're going to set our job ID there. Remember, strip out any dashes that are in there. Make sure it's 32 bytes in length. I'm going to grab my Oracle contract address here, and I'm going to add it here. Whoops, that's not right. Specify my Oracle contract. I've specified the job ID. We have our rank variable that we're going to store the off-chain data in. So now we're going to do our request. So we don't need to specify the URL in the request, but we do need to specify the player ID. So, whoops. So I'm going to add to the request player ID, and just so we can try and replicate what we were doing here, we'll do the same thing. So we'll put string Frosty, but in most cases you have this, whatever you want to send, you have it in a variable somewhere. But for the purpose of the demo, I'll just put it as a string here. So we're saying player ID is Frosty. We don't need to do any multiplication here. So really, it's just 3 lines here, building up the Chainlink request, just like a normal API call, to our specified job ID here. We're saying once this runs in the callback, call the fulfill function down here. And when we send the request, we want to send a parameter of player ID with a value of Frosty in there, right? And here's where the request is sent. And then in the response, we'll hopefully get the ranking back, and we want to store it on chain here. So that's the example contract. We're going to compile that, and we are going to go injected web3, Kovan, make sure you have the correct contract selected, and then we're going to try and deploy this to Kovan. A great question in the chat. What's the job ID pointing to again? So this job ID is you basically saying in your smart contract, hey, this is the job that I want to run on the Chainlink node that uses this Oracle contract. So when we created this job, it automatically assigned us a random external job ID. We didn't enter this in. Once it's created, you can automatically just see it in the job definition. So we basically just took this job ID out, and we stripped out all the dashes, and we put it in our consuming contract here as the job ID. Great question. So it looks like we have a contract deployed here, API consumer. Currently the ranking is 0. So what I'm going to do is, just like a normal API call, I'm going to fund my contract with some link, because I've specified here in the structure of the contract, the fee is 0.1 link for the node to fulfill our request. I'll send it some link. You don't need 0.1, but I'll just send it 1 anyway, in case I run the test again. And then we'll wait for that to complete in a few seconds. Once that's done, we will execute the request. So now we're going to go request ranking. And that's going to execute. So now if I go back to our node here, you can go to the runs tab, and you should see a job run come up here in your node. So job run 11. And as you can see, it's actually already completed here. So it's got all of our tasks in our job. So decode log, grabbing the log information from the emitted event log from the Oracle contract. We stripped out the player ID that we passed in here in the request. So make this a bit bigger, probably too big. This player ID that we added to the request was stripped out from the log here. So you see player ID Frosty. Here's our bridge task that we called, or we actually called the external adapter. And if I go to the external adapter that we're running here, you can see the output here. So it did that API call to our external adapter, and it got a bunch of JSON as a response, right? And then we parsed the response to get the data rank current value, so data rank current. So we stripped that value out and got 86 as a ranking. It encoded that value into a hex value here to send in the response, and then we built up a call to the fulfill Oracle request function in our Oracle contract that includes the data that we created and encoded up here, and then it submitted that transaction to Ethereum to our Oracle contract. So theoretically, if I go back to my consumer contract here and call the rank function, you can see that the ranking variable has now changed to 86 because the Oracle contract called the fulfill function here, and basically we grab that value that the job returned and we store it on chain. So there you have it. That was literally an end-to-end example of us using external adapter, right? So what we did was we defined what kind of data we want to use. We found an API in our Halo API here. We decided we want some Halo statistic data in our smart contract for whatever reason. We then took an example Node.js template and built up a simple external adapter that uses the API, right? That basically is able to hook up to the Halo API and basically grab data from it. We used an API key here and a .env file. And once we created that external adapter on our Chainlink node, we created a job that basically uses that external adapter as here. We also defined that external adapter as a bridge. Sorry, I forgot to mention that as well. And then once we had a job that uses the external adapter, we did a simple smart contract example of creating a smart contract that uses the specified job. So that's really it for the end-to-end demo. If anyone has any questions, feel free to ask in the chat. Otherwise, I'll just chat a bit about Chainlink Market now. So Chainlink Market can be found at market.link, and it's basically a market for Chainlink jobs, adapters, data sources, feeds, and data providers. Sorry. So excuse me, if I go to market.link, you can kind of see. If you go to adapters, you can see that a whole bunch of people have published a whole number of adapters that do various things. So, you know, you could even check here to see maybe your use case has already been taken care of and someone's created an adapter, right? Or if you create an adapter that you think others might find valuable, you can actually publish it to market.link here, right? So here's an IPFS, Chainlink external adapter for connecting to IPFS. As you can see, it's got a bunch of sample input, output. It's got instructions for using it, etc. So if you want to share your external adapter that you create with the community, you can definitely look at listing it here on market.link. There's a really great question in the chat here. I'm just going to bring it up. Let's say our adapter performs a computation off-chain and reports the result back on-chain. How do we make sure the computation is trustless? Yeah, that's a really hard thing to do, and it depends on the use case that you're going with, because in some cases, there's no way to verify that it's trustless or trust minimized. So, you know, you might have 3 Chainlink nodes connecting to 3 instances of the same adapter to do the same thing, just to kind of create that trust minimization. Or in some cases, maybe you can verify the result on-chain with some kind of on-chain data or computation. So it really depends on the use case. But yeah, you just need to be aware that doing things with a single node and a single adapter is not really decentralized. And for the purposes of the hackathon, it's 100% fine to do. But in a production scenario, you want to look at maybe decentralizing that to kind of create that trust minimization. So you could have multiple nodes running multiple jobs, like their own instance of the same job with their own instance of the same adapter to kind of create that trust minimization. Great question. So if you need to get help as part of creating your external adapters, the best place to go is in our Discord. So we have an external adapter channel, I'm pretty sure. So you can ask questions in the external adapter channel. If you create an external adapter but you don't want to or can't run your own Chainlink node for whatever purposes, there is an operators channel as well for reaching out to operator requests, sorry. So here's the external adapters channel. Operator requests, so you can ask node operators to host an external adapter for you and host a job that runs the adapter if you want as well. But if you have the time and bandwidth, I highly recommend to just try and spin up your own node and host your adapter locally for your hackathon demo, because that way you're in control of everything. You can make sure everything's all running and everything when you want to record your video. So other than that, once again, head to our docs for more information on external adapters. So go to docs.chain.link, node operators, and external adapters section down here. A whole bunch of useful information. That is it, guys. I will share a feedback link here. I see Evan's already added in the chat. Thanks, Evan. If you have any feedback on today's session, feel free to share it with us in the link there, or scan the QR code. But yeah, I hope everyone got something out of this. I really love external adapters. I feel that they create the most interesting hackathon submissions because they basically allow a smart contract to reach out to any API in the world, right? So people can come up with some pretty interesting scenarios for things that you can do with a smart contract, whether it's, open a weather gate or connect to a Tesla or connect to a enterprise financial system or something to handle a payment or things like that. So they really open up the possibilities for what you can do with a smart contract. So I hope everyone got something good out of this today. Really excited to see what kind of hackathon submissions we get that use external adapters. And if you have any questions or need any help, definitely reach out to us in the Discord or create Stack Overflow posts tagging Chainlink, and we'll definitely try and help you out where we can. But thank you, and all the best with the rest of the Chainlink Spring 2022 hackathon. Thanks, guys.